Hello, everybody. I am Bill Binko from AT Makers, and I'm thrilled to be on AAC in the cloud again this year. This is the third year I've done this for AT Makers. I think I might have done it once for Lesson Picks as well. And today we're going to talk about something a little bit different. If you are familiar with my other chats, the last couple times I was here, I talked about what's wrong with the AT industry and how the maker movement might help it. In addition, I had a video last year about how to engage your high school robotics team and STEM program to help you make assistive technology for your students or your family members. I'm not going to focus really on how to handle either of those things today. I'm going to focus on digitizing the intent. And this is something that I realized over the past year. We spend a lot of time following the same approach to solve a problem, and I'm not sure it's the same approach that a lot of other groups take. It's not the same approach that I've seen anywhere else, and it wasn't really codified until we sat down and talked about what we're doing and what's working, what's not. And I need to thank Chris Young and Jonathan Lasco and all the folks on Chad Lehman, all the people who have helped on the AT Makers Facebook group for trying to get an understanding of what's working right now in AT Makers and how we might be able to share that with others and replicate it more effectively. And before we get started, I do have some disclosures to make. It's kind of important that we do this. I have both financial and non-financial disclosures here. I run Lesson Picks. My wife and I founded it 10, 11 years ago, and it is an AT company. We make low-tech AAC and materials for learning and teaching. That's certainly a financial disclosure. I'm also the founder of atmakers.org, which is a nonprofit organization that is focused on bringing together the AT and maker communities. Finally, because this is AAC in the cloud and it is related to Cough Drop, I should probably point out that Brian Whitmer, the founder of Cough Drop, and I are working on a project called COVID Speak to help people use AAC when they are intubated or otherwise unable to communicate due to COVID-19. Now, if you've seen me around at conferences, AT conferences, ATIA, and things like that, you've probably seen me with groups of teenagers like the one here. And it is absolutely true that we spend a lot of our time teaching maker organizations how to work with assistive technology and teaching assistive technology folks how to be better technologists, makers. It is not our goal. It is something that we do a lot of in order to support our goal. So if you see me in those things, I love it. I love working with the teens. I love teaching people how to solder. I absolutely do. But the mission of AT Makers isn't to teach people how to be better solderers. That's really not the goal. The mission is to bring together these two communities. So we want to introduce AT users and maybe people who should be AT users to makers who can make their lives better through the ability to do electronics and 3D printing and modeling, Instamorph, low-tech stuff, all of that. Bring together the people who have this deep need of assistive technology, and the people who have great deals of ability and not necessarily the awareness of where they are needed. I show this picture in almost all of my presentations these days. If you've seen me do it before, I'm going to sound like a broken record, but this is my favorite picture of all time. The young woman in the middle, in the pink power chair, is Ella Hunt. This time I think she was about 5, maybe 6, and she could not drive her power chair. And so we worked with her and her family to make the ability for her to control the chair with 2 switches. So right turns right, left turns left, both goes forward. And with some timing and things we'll talk about later, a little bit of logic made it possible for her to drive. And I did that with a group in Elkhart, in Mikawasha, Indiana, called Penn High School, Team 135. I worked with a robotics team to help me get that installed and do updates on it, and also to work with Ella and her family so that she would have the ability to practice. They allowed her to use this enormous space that they have for their robotics competition And the woman on the left, the young woman on the left, who's now in college, is Italia Fields. At the time, she was a junior in high school. And I love everything about this. Ella is able to drive her power chair in practice. But the girl, the 17-year-old on the left, is having fun playing tag with a young woman, with a young girl, who has spinal muscular atrophy and is looking right through that. She's looking right through the CPAP. She's looking right through the power chair and seeing a kid who she's working with and that she's having fun with, and she's just playing. And everybody in this picture shows what's good about this. So on the right over here is Ella's mom, Erica. Here's her physical therapist who's delighted that she's able to move around this way. In the back are robotics kids who are taking pictures and posting it on their site and on their outreach part of their organization. And then there's Italia. And Italia is just having a ball. And I know that these kids are going to be better humans for having helped with this project. And I love everything about what's happening here. And this really is what I try to get to every time we're working with a maker organization. So this is what our goal is. It's not teaching maker skills, and it's not teaching assistive technology. It's trying to get these two groups to work together for the benefit of both of them, because everybody can see the benefit that Ella has here. But the benefit to Italia and to Erica, her mom, and all of these folks, everybody is doing better. Me too. I feel better at the end of this. Everybody does well with this, and that's really what we're trying to do. As we did this, as we started down this journey, Ella was the first person that really showed what digitizing the intent is about. And what I'm going to start with, because it's been so crappy lately, I'm going to start with a bunch of happy stories that make us feel better, and then show you the common thread that leads us to what digitizing the intent is all about. I hope you're good with that. All right, the women on my right here are Kylie and Christine Kramlich. Christine is the mom. Kylie is a young woman in the power chair. Kylie has cerebral palsy and uses a power chair to get around. She uses a PRC accent for speech generation, and she uses the Unity symbol set. Christine is actually works for PRC, which is how I got to know them. We were asked by Kylie to help her open and close her bedroom door, which seems like a minor request because it's a bedroom door, until you realize, no, she's 16, right? Or she was 16. And you want to be able to close your bedroom door. If you, any of you women, I've raised 3 girls, they want to be able to slam their door, but she didn't want to slam the door. She just wanted to be able to open and close her door. And the commercial ways to do that are really, really difficult. So she asked us, and I worked with a robotics team down here in Florida, and we got one made, and we made a device that allowed her to open and close the door. If you see right here, there's a motor that is mounted with 3M stickum strips, whatever they're called, command strips that stick to your wall. So it is mounted with command strips to her door with a motor. There's a little box we made over here that is sitting on her Wi-Fi network and listens to command to open and close the door and keeps track of how open or closed the door is. This is not rocket science, but a really great project for somebody who's in a robotics team, and probably cost us a total, like if we were making another one, it would cost us $75. I bet it cost us $120 because we failed several times. But we made this device, we installed it on her door, and then we needed to have a way for her to be able to control it. And Kylie uses a Unity, an Accent 1600. And so we wrote code, we wrote a small bit of code that allows us to put buttons on her screen that open and close the door. So if you look right here, you'll see a green button, which is open door, close door. There's also stop door, lock door, but lock just means don't let the wheels spin. So she can keep her cat out and things like that. These are things that were a huge change to her life. It didn't cost a ton of money, but we needed to be able to get her wishes into a piece of software to be able to open and close the door. This is still working. We've done another one more recently, also in Atlanta, and there are videos showing how to do this. I didn't mention this before, and I should have, but if you look at the bottom right of all of these slides, like this one of Ella and this one of Kylie, there's a little QR code. If you point your phone at it with your camera on, it'll take you to a video that shows you more about each of these stories. So I encourage you to do that. This video, this story is a little more controversial, and no teenagers were involved in any way in this activity. But we had a young man, Michael Phillips, and unfortunately, Michael Phillips passed away this year. He's a good friend of ours and a good friend of a lot of people in AT. He was an inspiration for over 30 years of somebody who had SMA type 1 and didn't ever let it stop him from expressing himself and advocating for himself. He's quite impressive young man. I read on his blog, which was not always appropriate for kids, but great reading, always great reading. He had a list, and he never called it a bucket list, but he had a list of things he wanted to do. And some of them were things that I completely couldn't help him with. Spend the night on a deserted island with a woman I love. Can't help you. But one of the things on his list was literally fire a gun with a switch. And I can help with that. I can totally help with that. So we went, I have friends who are gun owners and folks who run gun ranges. And they put me in touch with another gun range here in town that could work with us. I should be able to remember it. Reload in Tarpon Springs. And we actually had a fantastic day. We rigged up a Glock 19, Glock 17, I forget, a 9mm pistol that was held safely in a rest that was aimed downrange. We motorized the ability to pull that, and then we created a web interface you can see on the right over here, which is the view that Mike had from his laptop, from his Mac. And he had the ability to arm the gun by using his eye gaze, well, not really his eye gaze, his EMG switch on his forehead to row and column scan until this activated it and this fired the gun. And it's a fantastic video. Honestly, if there's only one video of mine that you watch that one, because especially in today's day and age, it is almost good political video. It's the only thing I've ever done that's almost good political video. But it was fantastic. We went to this range. Everybody worked together to make this happen. But again, it was getting his intent. It was getting, what is he trying to do? He's trying to arm and fire a gun. And all he can do is move his eyebrow. And we learned an important lesson on this one, which is everybody has a way to manipulate the web. Everybody can manipulate a browser because that really ends up being the window to the world for a lot of people. So rather than trying to figure out a way to hook a gun up to his switch, we hooked a gun up to the internal, not internet, into the Wi-Fi network that we brought with us, a little Wi-Fi device. And then we pointed his browser at that control. And that was a huge door, like a eye opener for us that said, a lot of times you don't have to figure out how to get to the switch, just web enable it. If you web enable whatever the item is, you're immediately going to have the benefit that folks have already figured out how to use the web. So this was great. Mike had a ball. His mom, Karen Clay, had a great day at a place I bet she never would have thought she would have a great day. She is as far left as you can get. She has healthcare voter tattooed on her hand. And she had a great day at a gun range with Mike. And there's a lot at the end of that where Mike explains why he wanted to do this. But it was wonderful. And again, it was about getting what Mike wanted, what his immediate intent was, digitized and into a form that we could then use using software. All right, Jim Lubin is much less controversial. He is a friend of ours from Seattle, and he is actually one of the more inspirational people you'll meet if you ever have a chance to meet Jim. He is the most upbeat, positive person you can imagine who hasn't moved since 1996. Right? So in 1996, he has transverse myelitis. He had transverse myelitis cut his spinal cord at C3 or something, some very high up number, and really he has no ability below his neck to move his body. Um, and he tells a story very well, if you ever have a chance to listen to him, of how he was laying there one day and he realized that he's going to have to figure something out, and he decided to learn Morse code. And there was a device back then, that he was using called an Adapt-to-You that would allow you to use Morse code to type and to move your mouse around. That was in 1990. I think he had the accident in 94, 96. He got that device, and he's still using the same device from 1996. In fact, there's a desktop that he has to pull out if he wants to reset or reprogram it, or if he loses power, because he's got to plug it in and put the floppy in, and all these crazy things that he has to do. If this device was ever to fail, he would be unable to communicate and to control his laptop. So he reached out to us, and we went and made him. We made him a device. We made him the device you see right here, which is it's relatively inexpensive. It is a Feather 80 NRF 52840. It's a Feather. It's a Feather microcontroller from Adafruit, and a little pressure sensor that is hooked up to a wire that goes through a tube to his mouth. And it allows him to use Morse code to type and to move his mouse. And it's got shortcuts for sending his email address. It allows him to control a computer and type remarkably fast, like 30, 50 characters per minute, right? Like, he's not touch type as fast, but he's way faster than he's going to be by using row column scanning on an on-screen keyboard or anything like that. And it's what he wants. It's what he's comfortable with, and it's something that he has gotten this down to a science. He has muscle memory, and it's what he wants. He had the original device back in the 90s, but replacing it has been a real challenge. And so by reaching out to us, we were able to recreate this thing for him. And it's probably a total of $40 for this. I'd say it's probably $40 to make one of these. It is a smart sip and puff device. One of the nice things about this is this experience allows us to work with people like Makers Making Change, which has the lip sync device, so the Morse code we did here is also feeding into the software that they're creating for their lip sync device. So Milad Ha and Chad Lehman and others are able, because this is all open source, they are able to take what we have learned and apply it. It's fantastic to see him succeeding with it, but it's also really good to remember that this is the same approach, right? What have you got? You've got the ability to sip and puff on that straw really fast and really accurately, and you've got the knowledge of Morse code. Great. Let's take that and make it possible for you to control your PC, your Mac, your iPhone, or whatever it else you want to get to. So the last person I want to introduce you to here is Chris Young. And Chris is more than an end user. If you're on the AT Makers Facebook group, which I fully recommend that you join, it's a great place to see everything from inspiration to problem solving to just really good ideas out there. Chris is also a maker in his own right. He doesn't need somebody like me writing software for him. He does that himself. But he's very limited on his physical mobility because he has SMA type 2. He's in his 60s. He's living his best life. It's remarkable to see what he has created in Indiana to allow himself to do what is important to him and to communicate, to be online, to do videos every week with Adafruit. And it is remarkable to see what he has done given the abilities that he has. Not the mental abilities, those are remarkable, but the things that he has done to overcome the physical challenges he has been really cool to see. The video on the little QR code on the right, wherever it is, over here, if you watch that, I did a tour of his home where he walks me through all of the things that he has created over the years in order to control his house, his lights, his television, his DVR, his computer, his 3D printer, his power chair, everything that he needs in order to be able to control the world around him, he has wired into the very limited motion that he has. So what Chris has is he can move his thumb relatively effectively. He uses the device right here, which is called a sling ring. It hangs from his fingers, and it gives him access to 3 switches. And with those 3 switches, he can activate each one individually. He can activate 2 together, 2 different ones together, or all 3 together, which gives him a total of 6 different activations that he can do with the same fingers. And he was able to write software that allows him to chord those, where 1 and 2 means one thing, 2 and 3 means one thing. He has a little device that you see on the screen there called an ultimate remote. It shows him on a screen, what are you currently controlling? What are each of your switches going to do? And lets you walk through whatever it is you're trying to accomplish. It really does take only 3 inputs to control a ridiculous number of things in his life. You'll also see that he's got a blue device that's holding a joystick on his lip. That's a device that he designed. The mounting point is a device that he designed. He 3D printed it that holds it on his mouth correctly. And that one joystick controls his power chair. When I met him, it only controlled his power chair, and he drives around ridiculously through areas that you'd never expect him to be able to using just his lip. But we were able to take that one more input from him, right? So we have the 3 switches that are already going into Maker electronics. We were able to take that joystick and use it as one more point where we can measure his intent, measure what it is that he is trying to do, and use it in a new way. The reason he's able to control those other devices is because of the work we did here. So this is actually a picture of a device right here that we made at the request of Steve Spawn and Able Gamers. Now, this device is something we made primarily for gaming to start with. Steve wanted to. Able Gamers is a gaming organization that helps people with disabilities, physical challenges, get involved in online gaming or individual gaming using the Xbox, the PS4s, and things like that. Turns out it's very empowering. It's very important, and it is something that a lot of people can control. Even if they have significant disabilities, missing limbs, or in the case of Steve, he like Michael Phillips and Chris Young, he has SMA, and that has limited his ability to move. He asked for a way to use the joystick that he already had attached to his chair to be able to control his gaming system, his Xbox Adaptive Controller specifically, and we created one. It wasn't really that hard. It's something that once we knew there was a need, the makers were able to answer some questions. The folks at Adafruit were great. We'll talk about them in a little bit. But we created this device right here, which you unplug the 9-pin adapter from your power chair, and you plug your joystick into this. And this then plugs into your Xbox Adaptive Controller and lets you control gaming. But it's so much more than that, right? So because it can capture the joystick input, we can actually use that input to do lots of different things. So that led, and there's another video here, is a great video that Able Gamers came out with. Feel free to watch that. We'd love to see you help us share this with other folks. But once we had this ability to capture the joystick and write software around it, it led to what we just finished, and what really sadly was cut short because of COVID-19. We went on the 2020 drone tour. Okay, so this is the 2020 drone tour that we did in March. So in early March, I flew around the country, and that stopped all of a sudden in March. But we flew to see all the folks you kind of met. So I went to Steve Spawn's house. I went to Chris Young's house. I went to Ella Hunt's house. And in all of those cases, we were able to take that device that we had made for gaming. We took the Freedom Wing that was meant originally for gaming, and we applied it to something different. In this case, we actually were flying a drone, a standard stock DJI Spark drone. We were using a custom piece of control software that some folks a gentleman in Italy, basically, a self-contained country inside of Italy whose name I forget, but I should remember it. Not Montenegro, but something like that. He modified his custom software that he had written for the DJI so that it could accept keyboard input. And because we could take this joystick input and convert it into keyboard inputs, we could make magic happen. So Steve Spawn in the upper left there, right here, Steve is using the joystick that is mounted to his to the table, the one that he uses all the time to drive his joystick. Chris Young up here is using the joystick on his lip. And Ella is not using a joystick at all. She has SMA type 1. It's more difficult for her to move a joystick. It's not really possible. So she's using the same 2-switch interface that she used on her chair. So right turns right, left turns left, both goes forward. And then we have a co-pilot who can change what mode she's in. So if she wants to go up and down, left goes up, right goes down. And she's able to fly around her neighborhood and explore her world, her real world, not the virtual gaming world, but explore her real world for the first time. It was really cute. There's a great video of her flying over and watching kids play basketball at the neighborhood park. And we're like, what are you looking at? Where are you going? And she didn't know there was a park there. She didn't know there was a place where they could be playing basketball. So this is another example of capturing intent, but it's kind of an important one because these are all intentions that we had already captured for other purposes, right? Ella already had the switches for her power chair. Chris already had the joystick to drive his power chair. Steve Spawn could control his power chair using the joystick that he had. And all of those, even though there are different motions, a hand joystick, a lip joystick, and 2 switches, all of them could be applied to fly the drone. All right, so what do all these things have in common? What is the point of sharing all these wonderful stories with you, and what do I want you to learn from it? It really comes down to this. Once you have digitized somebody's intent, once you have captured what they're trying to do, everything else becomes possible. And it's not necessarily possible for the person who is capturing the intent. It's not necessarily possible for the person who is installing the joystick. But if you are working with people in the maker community, if you're working with technologists, all of the other things you want to do are already solved problems. If you can tell somebody like me or a developer or somebody in your robotics team, we've captured the input, we have 3 switches that we're going to give to you as standard input, they can then adapt whatever it is you're trying to adapt. So in every case, this ended up being our process. And it's what I want to get through to you today. It's what I think if you take one thing out of this for me, make it be this, right? If you can separate the capturing of the intent, the digitizing of the intent, right? If you can separate that from what it is you're trying to do, it's really powerful. Because once you've captured the intent of that user, however you're doing it, whether it's a joystick or an eye gaze device or a pressure switch or a sip and puff, an EMG, a muscle sensor like Michael Phillips, no matter how you're capturing the intent, once you've captured the intent and digitized it into a form that you can manipulate in software, everything else becomes possible. So the process comes down to capture it, get it into software, add a little bit of logic. For example, in Ella's case, we only had 2 switches, right? But we wanted to be able to do 3 things. We wanted to be able to do 5 things. If you think about a compass, we wanted to be able to drive north, east, west, but also northeast and northwest. And so we could do that. So if she was stopped and she hits right, it spins to the right. And if she stopped and she hits left, it spins to the left. If she hits both, she goes forward. If she's moving forward and she lets up of the left switch, she curves. She goes northeast rather than stopping and jerking. That's just logic. It's a little bit of logic that you can put in software that says, am I currently moving? If I'm currently moving, I'm going to change to not stop and spin. I'm going to curve. That's all stuff that can be done independent of how you're sending in the inputs, whether it's a switch or joystick or anything else. So that's, step one is capture the information. Step two is do a little bit of processing and logic to do things like that of, oh, I'm moving, so don't stop and spin. And then perform the actions. And perform the action is solved every day, right? In the maker community, people make keyboards out of everything. They make things that drive lights out of whatever input they have. The ability to activate something over Alexa, the ability to check your weather, the ability to change your lights, to change your thermostat. All of these are already automated. It's now just a matter of connecting the input that has been processed into the action that you want it to take. So the goal of this, what I'm trying to get across here today, is to please separate out capturing the intent, digitizing the intent from what it is you're trying to do. All right, so I know some people are looking at the right-hand side of that and saying, I don't know how to do any of that stuff. And I get it. There's no doubt about the fact that the right-hand side of this can be intimidating for a lot of people in the AT world, a lot of people who will be at AAC in the cloud. It's really split this way. The right-hand side of this process requires people with some level of maker skills, some level of technology skills. The left-hand side requires people with very specific AT knowledge. So if you're going to be choosing, placement of switches, if you're going to be determining the best way to get activation, or you're looking at repeatability, or you're looking at fatigue, that's an AT thing. It's an occupational therapist thing. It might be a speech path thing if you're doing things that are voice controlled. I get that there's a split there. What I want to make you aware is two things. We do a lot of this ad hoc right now, and we false start, and we work our way through it. We are working towards a process, which I'll explain in a minute. But I want to make sure you guys understand that on the right, there's a lot more help than you expect. So we have a relationship with a lot of folks in the maker community. And I have a video, you probably saw it, an old AAC in the Cloud video on how to engage the maker movement. There are a lot of people in the maker movement, in the maker world, who are really not just willing to help you, but excited to help you get through the right-hand side of that map, that right-hand side of that process. There's folks in maker spaces like Ian Cole. Becky Stern in the center right here is wearing an EMG device on her forehead and wrote up exactly how to create one. And the woman on the right is probably our most important, or her company is probably our most important maker partner, which is Adafruit. I'm going to show you a video of Lamore and her partner, both husband and partner, Phil Terone, where they're talking about, she's originally asked, where do you see the maker movement going in the next 5 years? And I show her answer. And that was several years ago. That was maybe 3 years ago. After that, you'll see a video very recently where Phil and Lamore are talking about their involvement in assistive technology and how important it is to them.
If you're someone who needs special hardware and you don't have that skill set, it can be very, very expensive and challenging to get that stuff made for you. But there's people in the maker community who are like, oh, you just need a really big button that sends a keyboard press to your iPad. And there's just nothing on earth that does that. And so I'll make that for you. And so the ability to custom make hardware, and that ties together with open source hardware, right? If it isn't open source, it's not possible to do. So having open source hardware and have it be easy for people to customize it has allowed the accessible technology community really mesh well with the maker community, which I think is very interesting.
And one note about the assistive tech. So that was a big surprise for us in the last few years. We're not an assistive technology company, but when you make something so easy to use and it could be distributed to others. So there's so many things that you get when you start doing stuff with Feather and CircuitPython that Bill Binko from AT Makers does a lot of stuff with feathers. There's things that people specifically made for assistive technology. So that's always really neat to see. I think maybe next year, if we do another contest, we could do one for all the different types of assisted technology. There's enough stuff going on just with Feather alone. I
Absolutely.
know
Yeah.
that's the Hackaday Prize thing, but that's always good to see, because imagining what you can do with technology that can help others, and
Right.
we're all going to need
Sure.
assistive tech one day. That was really good to see. Very, very heartwarming, and makes me have some hope.
So they're not just willing to help us make assistive technology tools. They're actually excited about it. It's something that they love about their companies, that they're able to help. And I've got things here on the screen that are kind of important to show. These are all devices that Adafruit either made or modified specifically for AT makers, right? Not just for AT, but like for us by request. The big thing in the upper right, which is a fantastic tool for assistive technology folks. They modified the software in it so that it could control switch control on iOS. It was a high priority for them because they knew we were waiting on a way to control switch control using capacitive touch and vibration control and all the things that are built into that board. They released this adapter here, which allows you to connect to one of these boards using alligator clips, not soldering, and have an AT jack so that you can control that device directly. This is the ported pressure sensor that we used on Jim Lubin's sensor, which they made directly because they knew we were looking at sip and puff solutions. The relay control right here, which is the next one over, is a design that I sent them, and I said, this is what we need. She made it better by placing the solderless connectors on it, and then made it and put it in their store, and you can buy it for like $7 now. And the last one over here is the digital potentiometer. This is something where I was just looking at a possibility. I saw a way to be able to control PowerChair or other RNet devices using digital potentiometers. Basically, it would let you emulate one of these 9-pin joysticks. And she went through an entire process with me of choosing the device and then made the breakout board, which makes it easy for us to be able to use it. So this is an organization, Adafruit, and there are others. SparkFun has done stuff for assistive technology. DigiKey has. There are people in the commercial maker community, not AT community, but the commercial maker community, who are actively working to help support us. Now, today, finding those folks is a little bit tougher. My best advice is join the AT Makers group. And that's going to sound immodest, but I really mean it. Right now, one of the best places for you to get involved with people who are makers and are making assistive technology is our Facebook group. And that's true if you're reaching out to makers making change, they're all on our group. And if you're working with able gamers, they're all on our group. Like this, if you're working with Adafruit, they're all on our group. There are a lot of people there who are willing to help you come up with a unique solution that fits your needs. And most of the time, they're going to follow the process that we talked about. We are trying to make this more robust. And so the next stuff I'm going to talk about is currently in development is the best way to say that. So we have come up with an approach that we would like to be rolling out, and we're probably going to partner with some research folks at universities to try and make this much more official. And we call it an impact process, mainly because I like the acronym. But if we can actually document and codify how to do this a little bit better, I think we'll get a much better end result, right? So this is the process that we follow now. We inventory what the user wants to do, what they can do, what is their endurance, what are they able to move, what could we measure. Very often that is done with an occupational therapist, with an ATP, with parents and other folks who know this person well enough. And sometimes they're not communicating on their own effectively. But we can do an inventory to see what are their skills and their abilities. And that's really not my strength. That's not what I am as a technologist. That's much better off in the hands of an OT or an ATP. The next step isn't necessarily done in most cases, but it should be, which is to measure. Don't just tell me they can move their finger. How much force can they apply? How repeatable, how consistent can they be? Is it possible we could get a double click? Right? Is it possible we could get a light press and a hard press? What are the measurements around the thing that you're trying to capture? And the big problem there is the tools aren't available to an ATP, and we are trying to fix that. We are trying to make an open source set of tools based around Adafruit hardware, things that aren't designed for AT. Like they have a Pi Gamer is probably what we use for the screen to be able to do this measurement, but a set of measurements that you can actually get real numbers, so that when you go to a technologist, you can say, it's not just, yeah, she can move two of her fingers. It's, here's the amount of force she can apply. Here is how repeatable he is on that action. Here's the range of motion in terms of the number of degrees. Measure that, and hopefully have that be measured by people who aren't necessarily technologists, right? Ideally, the AT folks should be able to do the first steps of these process without involving the maker team, the robotics club, the whoever it is that you're going to use as your technologist. The second two steps are technology focused. So add a little bit of logic, add the ability to do chording. So like Chris does on his sling ring, use two switches to mean something different than each of the two switches separately. Do debouncing. If you have somebody with a tremor, you can add debouncing in software that will make it possible to determine, yes, that was an intentional press versus an accidental press. That's something that is just software. It's just software that you write. It's repeatable. We can have libraries that make it easier to get forward, to move forward. And it's something that already exists in a lot of maker spaces that just aren't specific to AT. So process that. Amplify the signal you're getting out of the person so that instead of having two switches, you have 5 directions. Instead of having 3 switches, you have 6 inputs, right? All of those are things that you can do in processing if you have a little bit of software knowledge. And finally, activate the thing you're trying to control. This is not an AT thing at all. If you're trying to turn on a light switch, right, it's just a smart switch. It's a Wemo plug that you plug into the wall, and now you can do it. Hooking up that processed input to the activation code is a simple thing for makers and a difficult thing for ATPs. So ideally, that would be done by makers and technologists. Now, in order for this to work, we have to actually have one of two things. Either we need to get ATPs who are also makers, and we are doing that. There are a lot of OTs who would like to be doing a lot more maker work, and we're trying to help that happen. It is harder to go the other direction. To get makers to be able to have the interaction with a person with disabilities early in their process is a much harder ask than to go forward and train ATPs to be more makerish, whatever that word is. We can do that. Much more likely to be successful is we can get these two groups to collaborate. So it leads us to our pitfalls and where this breaks down and where it fails. What are the perils? Well, the biggest thing is AT professionals need to work with technologists, and neither maker skills nor collaboration with technologists is being taught today. So this is something that we are actively trying to help fix. So I am reaching out to universities. I worked with Bill Janes in Missouri at Mizzou. I've worked with a number of people that we need to start both. We need to teach more maker skills to ATPs, and we desperately need to teach collaboration and how to work together with your technologists. The next thing is that these things don't scale well, and I don't really have a solution for this. If you look at the things that we've created recently, the IntelliKeys adapter, the Freedom Wing, we can use the robotics teams to make dozens of them at low cost as part of their outreach program. But when you go beyond dozens of a solution, this doesn't necessarily scale well. So what does scale well is getting the software standardized, published, open source, and shared, but actually making a lot of these devices we haven't figured out how to make it scale well. And that's something that we're working on. Individual solutions, individualized solutions is probably a better term. Things that are made specific for one person inherently aren't going to scale well. The best we can do is document what we do so that people aren't starting from scratch in the first place. Support is very difficult, and it's something where it almost requires something official so that technologists who are working within a program like this can charge for support and repairs, and the money that normally would flow into commercial products that are very expensive could be leveraged for that kind of support. I don't know a good solution to that. And lastly, liability concerns means that some things we're not going to be able to do. The gun. The gun was something that could only be done by individuals working directly together. That will never be repeatable. There will never be a product that anybody will ever sell to be able to automate a gun. It's just never going to happen. The amount we had to work with the federal weapons, the ATF. It's not called the ATF anymore, but the firearms organization for the United States had to approve what we were doing. That's the edge of where you can. That's beyond the edge of what we would ever recommend that you do on this. But the approach is still correct. Okay. I think these are where this breaks down. But there's something important to be said for not letting these things make you stop. Probably the most important thing there is if you have somebody that has any way to get their intent known to you as an individual, the goal should be, all right, I can see what this person is trying to say or move. I can feel it when they press my finger. What is the sensor that might possibly be able to digitize that? When you've got that, when you have it in your head, don't ever let somebody say, oh, there's nothing in the catalog that does that, right? Don't ever let somebody say, oh, yeah, there's no way to control your lights with that. We can let you type, but you can't send an email. Like, that doesn't make any sense. We need to stop thinking about that. If we focus on taking the person's intent and digitizing it, it immediately allows us to look at the possibilities separately. All right, I can get that one piece out of you. What are all the different ways that I can actually apply that? So my request for you is to not let limitations of commercial products get in your way, and to try to think separately about what the user can do and what they're trying to accomplish, right? If we split those two things and you reach out to people in the technology community, it's really amazing what we can accomplish. So thank you for your attention. I hope you get something out of this. Please reach out to us at atmakers.org. You can join us there, sign up for newsletters and stuff. More importantly, and I hate using Facebook for this, but we use the Facebook group because so many of the support groups that we work with are already on Facebook. And it is fairly accessible. People can actually access it. So join our Facebook group. Tell us what you need. Tell us what you can do. Tell us where we're wrong on this, right? All this is at this point is a little bit of extraction of experiences we've had and something in common that we think is worth sharing. I'd love to get it to more than that. If you'd like to be involved in the impact process and our attempt to do some research around how effective that is, let me know. I am Bill at atmakers.org. I'm easy to reach. And as always, good luck and have fun.